Okay, today we're going to do the introduction to matrices, H9A and H9B. So first of all, before we can get started to talk about matrices, we're going to talk about order of matrices. So this is all in the introduction to matrices with Revision Village. All you have to do is go to YouTube and type in Revision Village Intro to Matrices, and there's a really great tutorial. But you've got me also. So when you talk about order, we're going to be using the word order of matrices, and basically the very first thing of the order is the number of rows. So so this has to do with rows, the very first thing, and the second thing has to do with columns. So this is the number of columns. Okay. So notice in matrix C, there's 2 rows and 3 columns. Okay. So so the next thing we're going to talk about is addition and subtraction of matrices. Okay, so you can only add or subtract matrices that have the same number of rows and columns. So in this example here, in matrix A, we've got 4, 2, 5, and 3. In matrix B, we've got 6, -2, -4, 7. So these were both matrices that are 2 by 2. So all you do is you add the 4 plus the 6 to give me 10, the 5 plus the -4 to give me 1, 2 plus -2 to give me 0, 3 plus 7 gives me 10, and so on. Now, later on we're going to talk about using the calculator, but I'm going to show it to you right now. And this just says what I said about you have to have the same order in order to add them. So if I wanted to type this into my calculator, you might want to hit pause to copy these instructions down. But I have to hit second, and this button here, X to the little -1, notice in blue writing it says matrix. So I push that, and I've got these matrices. I've already typed in all this stuff, but I'm going to type in a new one, right? So we go over to edit. If I want to type this matrix in, I can. We'll do that in just a minute. Okay, let's move to the next page. Okay, so before we type in matrices, let's talk about the next topic here, which is a scalar. So if I've got a scalar multiplication, it's pretty straightforward. So in this example, my matrix A is 1, 2, 5, 2, 0, 1. And if I want to multiply it by the scalar 3, basically all I'm doing is multiplying everything in here. I'm multiplying every single value there by the number 3. Okay. And by multiplying every single value there by the number 3, now we get the same matrix except everything is 3 higher. Okay. Scalar multiplication is rather straightforward and simple. Now, matrix multiplication, this is where we're going to slow down and take our time. So if I've got a matrix here and matrix B here, what we're going to be doing, so in order to get a product of 2 matrices, the number of columns has to equal the number of rows for the other matrix. So here I've got a 2 by 2 matrix, and here I've got a 2 by 2 matrix. So the number of columns, so remember the first one is rows, the number of columns of the first matrix has to be equal to the number of rows in the second matrix. Okay. And so how it works is, in order to get this cell, this value right here, I'm going to have this row times this column. So I have A times P plus B times R. Okay. Now this one over here, I'm going to use, to get that one here, we're going to have this same row. We would have the first row, which is the A and the B, and the second column. So I have A times Q plus B times S. You might want to hit rewind and listen to this process again. Let's do the next two. I'm going slow over this part because this is the part that's the trickiest. So now I'm in the second row, first column, right? This is the second row, first column. So I have the second row here times the first column of B. So C times P plus D times R. And this last one here is the second row, second column. So we have the second row and the second column. So I have C times Q plus D times S. Okay. Now here I've got a 2 by 3 matrix and a 3 by 1 matrix. So the number of rows, this is the number of columns, and that matches the number of rows on this one here. So now I've got so for this one here, I'm going to have this top thing is the row 1, column 1. So A times X plus B times Y times C times Z. And this here is row 2 times column 1. Okay, and then we end up with a 2 by 1 matrix. So let's just practice this here. Okay, this is the first example from revision village of matrix multiplication. Notice the handwriting matches the revision matrix guy. So this yellow value here is the first row times the first column. So we've got 4 times 6 plus 2 times negative 4. This blue one here is the first row, second column. So our first row, I'm going to use the 4 and the 2, and the second column, I'm going to use the negative 2 and the 7. So 4 times negative 2 plus 2 times 7. And then here, I'm going to do, this is the second row, first column, so 5 times 6 plus 3 times negative 4. And this one here is the second row times the second column, so 5 times negative 2 plus 3 times 7. Okay, and you get your answer here. Now let's do this with the calculator, because I want you to be able to check your work as you do these. So, okay, let's zoom out a little bit. Okay, so you can see all what's going on. Okay. Okay, so what I'm going to do here is, so you hit second and x to the negative 1 to get matrices, and then I'm going to go over to edit, and then I'm going to hit enter. And I'm going to type in matrix A, which, so notice here it says 2 by 2, so I want a 2 by 2 matrix. And now I'm going to type in 4, 2, 5, and 3. Okay, so now I've got the matrix that I'm pointing at here, this matrix A. Matrix A. Okay, so second mode to quit, get me out of there. Now let's type in matrix B. Second, x to the negative 1, arrow over to edit, and I'm going to arrow down to matrix B, and I'm going to hit enter. And notice it says 2 by 3, but we want to do a 2 by 2. So I'm going to hit 2, enter, 2. So now we've got a 2 by 2. And I'm going to type in the values 6, negative 2, negative 4, and 7. So now my values here match what's on the paper. Second mode to get out of here. So now I want to multiply matrix A times matrix B. So second x to the negative 1, and now it says name. I'm just going to hit enter, and now it shows matrix A. I want to get matrix B, so second x to the negative 1. I'm going to arrow down to matrix B and hit enter, and now I've got matrix A and matrix B, and da-da-da-da, 16, 6, 18, 11. So it's important for you to know how I got these values, how you do the rows and the column multiplication, but I'm going to want you to know how to do this on the calculator too. Okay, we're going to be using the calculator throughout this chapter. Okay, so this exercise on this page with Investigation 1 was just for you to practice figuring out how many rows and columns we have. So 2 by 2 is pretty easy, right? So matrix B, we know, has 2 rows and 3 columns. Okay, and when the number of columns on the first one matches the number of rows on the second one, then we can multiply it. And all of these, notice the number of columns on the first one I've highlighted in yellow, and this is the number of rows on the second matrix, and notice they match, and we get our product dimensions here. So you may want to check your answers here. I'll just let you see here. So factual, based on the results of what we just did in question 1, explain how you determine the dimensions of the product of 2 matrices. So basically the dimensions of the new matrix is going to be the number of rows of the first column by the number of columns in the second matrix. Okay. So, so explain why the product of BA and CB and BD cannot be determined. So if you look at matrix B, it's a 2 by 3 matrix. And if you look at matrix A, it's a 2 by 2 matrix. So the number of columns in matrix A does not match the number of rows of the second matrix. And as we did in our earlier example here, we can't follow this process of multiplying the row times the column that we did here if the number of columns of the first matrix doesn't match the number of rows of the second matrix. Okay, so I will let you check your work here, and let's move on to the next one. Okay, so multiplication of real numbers is distributive. Okay, what does distributive mean? So I've got A times B plus C. Oh, wait, I just missed something very important. I'm going to go back. Okay, so multiplication of real numbers is commutative. So I have A times B equals B times C, right? So for example, if I've got 5 times 4, that's the same thing as 4 times 5, right? Now the question is does this work with matrices? So I'm going to type in these matrices for us to see. So matrix A, second x to the negative 1, matrix. I'm going to edit. I'm going to type in matrix A. We've got, it's a 2 by 2 matrix. We've got negative 2, negative 3, 4, 1. Okay. Second mode to quit. Let's type in the next matrix, arrow over to edit, down to matrix B, enter. Okay, negative 1, 5, 6, negative 2. Okay, I've typed in the second matrix, second mode to quit. Okay, so let's see what is the result of matrix A times matrix B. So second, x to the negative 1, I'm going to pick matrix A. Second, x to the negative 1, I'm going to go down and pick matrix B. And then I get negative 16, negative 4, 2, and 18. Okay, now I'm going to do it the reverse. What is matrix B times matrix A? So second, x to the negative 1, matrix B. Second, x to the negative 1, matrix A. So matrix B times matrix A gives me... Uh-oh, I made a mistake, didn't I? Okay, well, this is supposed to be 22. Okay, well, maybe we can help me figure out what mistake did I make. I should have had negative 1 times negative 2 plus 3 times... Oh, whoa. Negative 1 times negative 2 and 5 times 4. Oh, that makes sense. It should be 22, right? Because this will be positive 2, and that should be positive 20. Okay. All right. So, as you can tell, these are not the same. Since these are not the same, that means matrix multiplication is not commutative. So, in regular algebra, multiplication is commutative, right? 5 times 4 is the same thing as 4 times 5. But matrix A times matrix B gives me this. Matrix B times matrix A gives me this. These are not the same. So matrix multiplication is not commutative. Okay. So now the new question is distributive property work with matrices? So these are the same matrices as the previous page. So matrix A times B plus C. So and so the very first thing I did was I found out what is B plus C. So let's type in matrix C here now. Okay, C is a 2 by 2 matrix, negative 2, 1, 3, negative 4. Okay. Second mode to quit. And so now I'm going to do B plus C. Okay, so matrix B plus matrix C. And I get negative 3, 6, 9, and negative 6. Okay. And now I'm going to multiply matrix A times this. So, and if I multiply matrix A times this, I get this value. Okay. And if I multiply matrix A times matrix B, I get this. And if I multiply matrix A times matrix C, I get this. And if I add these two together, I get this. And voila, notice they are the same. You might want to hit pause and check my work to see if it makes sense. You may want to hit pause and check that my calculator steps make sense. And also on YouTube, you can change the speed of my talking. You can make me go extra fast, or you can make me talk really slow. So whatever works for you is a good idea to do. Okay, so multiplication of real numbers is associative. So A times B times C is the same thing as A times B times C. So so what they wanted you to do is they wanted you to multiply B times C first, and I get this. And if I multiply A times that result, I end up with 20, 0, 50, and negative 70. If I multiply A times B first, I end up with this. And if I multiply this times matrix C, I end up with this. And we end up noticing that they are associative. You might want to hit pause to see, to check your work. Now, this right here is called the identity matrix. We have 1, 0, 0, 1. Okay, so they wanted you to multiply matrix A times the identity. So matrix A is -2, -3, 4, 1, and we multiply it times the identity. So -2 times 1 gives me -2. -3 times 0 is going to give me 0, and so on. 4 times 1 gives me 4. 1 times 0 gives me 0. Whenever you multiply any old matrix by its identity, you will end up with the matrix you started off with. And it doesn't matter the order here. I could have the identity first and then the matrix, and I will also get the what we started with. Okay, so conceptually, what have we just figured out? So matrices are not commutative, but they are associative. Okay, so there we go. Hit pause if you needed to check things out. Okay, and once again, this is the properties we just mentioned here. So now this here, so it talks about the identity matrix, and people were asking in class, what does this lowercase number mean? Because the very last question had a lowercase 2 here, and you're like, what? Why is there a little baby 2? Wah. So when you see the lowercase there, that means that we're just dealing with a matrix that's 2 by 2. Okay, the matrix, the identity matrix has to be a square matrix, which means the number of rows and the number of columns has to be the same. If it's not a square matrix, you can't have an identity matrix. It only happens when it's a square, where the number of rows and the number of columns matches. Okay, so we'll be practicing that in just a minute. Okay, so explain why this matrix cannot, why we can't multiply this, and once again, like the earlier ones, the number of columns in matrix A does not match the number of rows in matrix B. Okay, so let's do this one here. 3 times -1 plus 1 times 2. To do right here is going to be -1 times -1. Oops. Plus 0 times 2. And then here we're going to have 3 times 1 plus 1 times -1. And then this last one is bottom row times second column. So we got -1 times 1 plus 0 times -1. And we should get I'm just going to do it with the calculator just to make sure I lead you to the right answers. So we got 3, 1, -1, 0. And matrix B, we've got -1, 1, 2, -1. Okay, so multiply matrix 1 times matrix B, enter, enter, and I get -1, 1, 2, -1. Okay. Once again, I'm going to do this one with the calculator too. So, okay, 2, 1, oops. 2, 1, 0, negative 1. Okay, let's enter the next matrix, which is 1, negative 3, 2, negative 1. Second mode to quit. Second x negative 1. Okay, got the first matrix times the second matrix, enter, and I get 4, negative 7, negative 2, 1. Okay. So you can use your calculator to check your answers. I just did these two with the calculator. And I did all of these with the calculator. So okay, check your answers. Hope this helps.